Today's learning intention is to calculate the volumes and capacities of various prisms. The QCAA formula sheet formulas have been included, which include the volume of a cone, cylinder, prism, pyramid, and sphere. Volume is the amount of space occupied by a three-dimensional object. A prism is a shape that has a uniform cross-section along its length or height. This includes rectangular prisms, for example a cardboard box, triangular prisms such as a block of Toblerone, and in the diagram we can see below, or cylinders, for example your tin of Milo or other various tin food, or maybe a water tank. And again seen in the diagram below. You can see that with the two diagrams, a prism can be either sat upright, like you can see with the cylinder, and where the cross-sectional area would actually be the circle. So when we talk about the cross-sectional area, we often refer to the area of the base. So in the case of the cylinder, the base is and we'll colour it in. So we've got this shape here, the circle that sits on the bottom, and as we can see from the cross-section, it follows through, and again right through the shape up to the very top. In comparison, the triangular prism on the left, it's laying down. So the cross-sectional area this time would in fact be the triangle, because we can slice that block of Toblerone, say, or whatever our triangular prism is, we can slice it the whole way along. We can slice it here, 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 and we're always going to see that same shaped triangle. So again, the triangle becomes our area when we're referring to the area of the base. Now the difference between these two, and we'll clean that all up, the difference between these two also is that we talk about the height. Now for the cylinder, the height's easy. It's simply the upright height as we have shown. However, for the triangular prism, because it's laying on its side, your height is actually what we're referring to as the length. Okay, so the distance from the first triangle at the front to the triangle at the back. Okay, so we're saying, well, what's the height between those two triangles? Or for the cylinder, what is the height between our two circles? Okay, so basically anytime we look at calculating the volume for any prism, we need to have our volume equals our area of the base times the height. Okay, so, and I've explained the idea of the area of the base being that cross-sectional area, and the height obviously may be either the horizontal or vertical height depending on the way that the shape is positioned. We have our rule here, so you may want to pause the video and write that down. So you've got your general rule, volume equals area times height, and our units for volume are typically in either millimetres cubed, centimetres cubed, or metres cubed. We also talk about capacity. Now, capacity is different to volume. Volume was the amount of space that an object takes up, whereas capacity is the amount of substance that a container can hold. Okay, so if you think about like the amount of Coke in a Coke can, the amount of water in a pool or a bathtub, the amount of ice cream in an ice cream tub. So those are things that we're looking at. How much does it actually hold as opposed to what space is it taking up? And our capacity units are millilitres, litres, or kilolitres. If we want to convert between our volume and our capacity units, 1 centimetre cube is in fact would hold 1 millilitre. Okay, 1 metre cubed would hold 1,000 litres. So if you think about, you know, a 2 litre bottle of milk, well, you'd fit 500 of those in the space of a metre cube. Remember, a metre cube is 1 metre high, 1 metre to the side, and then 1 metre deep. Okay, so if we're thinking about a metre cube, 1 metre by 1 metre by 1 metre, it's quite a large thing. So that's why it holds 1,000 litres. Okay, and then 1 litre, well, we know 1 litre is 1,000 millilitres, milli meaning 1,000th. So if we have 1 litre, we can also hold 1,000 centimetres cubed because we know that the centimetres cubed and millilitres are the same. We have some popular formulas here for some common prisms. So again, if you want to pause the video, you can write those down. And then we're going to go through a couple of examples. All right, example 1. So we've got here a volume of a rectangular prism. Now, I've told you already that when we're calculating this, our volume equals our area times our height. Now, for a rectangular prism, we can also look up on it what we were just looking at before, and it actually tells us that the volume is length times width times height. Now, if you think about that, the idea would be that your base is your length times your width, so that's your base there, and then you're multiplying it through by the height. So it essentially can still work with that original rule, or you can just remember it as being length times width times height. So our length of the rectangular prism to the left is going to be, now again, it doesn't really matter, we'll call this the length, we'll call this the width, and we'll call this the height. So our length is 12. We're going to multiply. Now again, that rule doesn't tell us that we need to multiply, but in algebra we know, mathematicians, we're a little bit lazy and we should be multiplying between each of those letters. So 12 times our width, which was 6, times our height, which is 4. So we can either put that into a calculator or you can try and use your brain. So 12 times 6 is going to give us 72. 72 times 4 is going to give us my brain isn't working. I'll put that in the calculator. So 72 times 4 is 288 centimeters cubed. All right, perfect. Now, again, we may be asked to find the capacity of that. So it could be simply a matter of asking in milliliters how much it would hold. So it would be equal to 288 milliliters, because we know that centimeters cubed and milliliters are the same thing. All right, so if we wanted capacity, we can do that, okay? Because again, 1 milliliter equals 1 centimeter cubed. For our volume of a cylinder, so again, we can write our generic rule, area times height. Now this time, our area is our circle. So this is our area of base that we're referring to. So instead of using area, we're going to put in the area of a circle, which is pi r squared. And again, we're still going to multiply by height. Now again, I haven't done the times in between each of those, but we know that we need to. So when we go to substitute in, that's what we'll do. So we're going to say pi, so pi being 3.14 times, and obviously continuing, times the radius. Now we are given the radius in this particular example, so it's just simply 5 squared times the height, which is 25. Now I'm going to put approximately equal to. This little symbol here is approximately equal to, and the reason for that is because we aren't going to be able to get an exact answer because we're going to need to round, okay? Now, when we put that into the calculator, it'll give us a number of decimal places. Typically, I round to 2 decimal places unless the question asks you to do something else. Always make sure you read the question carefully because it is important that you do correct rounding. So, one other thing before I go to put those answers in, sometimes instead of a radius, you might be given the diameter. So this cylinder, you may have been given that the diameter was 10 meters, and so you would actually need to work out your radius before working out the volume like we just did, and you'd have to just simply get the diameter and divide it by 2. Okay, so 10 divided by 2 would give you the 5 meters, and then we could continue on. Okay, so I'll put that in the calculator. We've got pi multiplied by 5 squared, and you can use your little x squared button on your calculator to do that, and then times 25. And that gives us 1,963 point. Now let's say we're going to 2 decimal places. Now currently it is 4, 9, 5, 4, etc. If we want 2 decimal places, we look at the 3rd digit after the decimal, and in this case it's a 5. Any time that it's a 5 or higher, we round up. Now in this case, when we're rounding up, we need to round up from 49. So the number after 49 actually goes up to 50. So we're just going to clear that, and we're going to write it in to because it still needs to be the 2 decimal places, but we're going to write it as 50. And again, units, volume will be meters, and it's cubed. Again, if we want to go to capacity, so if we say, for example, this was a water tank, and we want to say, well, how many litres does that hold? Now, 1 metre cube, we said before, actually holds 1,000 litres. So if it's already holding 1,963.5 metres cubed, we have to multiply that by 1,000. We're going to get quite a large number. So we'll go 1963.5 litres. Okay, and in fact we could say how many kilolitres that is, because that's such a large number. Now 1 kilolitre is 1,000 litres, so we divide that by 1,000 and we're actually back to where we started. So 1963.5 kilolitres. So you can see 1 metre cube is in fact 1 kilolitre. Okay, perfect. All right, last one. So the last one, we've got another example. Now, as we spoke at the very start, a prism can be any shape as long as that cross-sectional area continues through the whole shape from one side to the other. In this case, we've got a trapezoidal prism. So there's a trapezium at the front, and that's our area at the base, and it continues through. So we could have a star-shaped prism, we could have a jelly bean-shaped prism. It could be anything we want, but we need to be able to find that area at the base. So our rule again remains volume equals the area times the height. Now, our area for a trapezium is half A plus B, being the top and bottom of the trapezium, the parallel sides, and times the height. And then again, we're timesing. Now I'm just going to use a capital H to represent the height of the actual prism. Okay, so our capital H is here. Our A and B are your 10 and your 15. And the height, little h, we're going to call for the 6, the height of the trapezium. So half A, which is 10, plus B, which is 15, times, now our height is 6, times our height of the prism, 25. I'm going to input that into the calculator. Now, half you can put in, I'm lazy, 0.5 I always write, times, now we can add that, so 25 times 6 times 25 equals, and so we've got an answer of 1,875, and again units, centimetres cubed. Perfect. Thanks for